thank you, CTBUH, for giving us an opportunity here for us to share our experience working on the Ping An Finance Center for the past 10 years. So to start with, we're going to show you a video, try to get you into the mood as to what kind of experience that we are having in this past 10 years. Okay, let's see. When we were given the notice to make this presentation, there are many things that we would like to share with you today. I guess the list goes on. And in summary, I think today we want to bring to you like 3 major points or 3 major things that we have gathered for this project in terms of the construction. The first one is the height. Well, we are not the tallest in the world, but certainly I can claim that we are the tallest within our group here today. And by being tall, it also means like we are working under extreme conditions, whether it's the wind condition or whether it's a very long period of constructions. So that's the challenge associated with the height. And in addition to it, it's also meaning that we are digging very deep into the ground in order to support this almost 600 meters tall buildings. Another one we would like to talk about is speed. There is this term called Shenzhen speed, which normally is associated with the economic development that happens in Shenzhen within the past 30 years. But in terms of speed here, we are also going to talk about some of the things that we are going to, how to speed up the construction. And then the last one is safety. Okay, this is the building that you are seeing today. And in terms of speed, I would just want to say that the speed we have talked about here does include, like, for example, the mat foundations that we are building. In fact, like within the 72 hours, we were to pour in like 32,000 cubic meters of concrete. And that, if you converted it into a terracotta warriors, which is one of the figures in Chinese, like a historical tomb, that will be about 416,000 of terracotta warriors, that kind of concrete volume. And in terms of speed, I can also talk about the speed in which the tower is rising in the past, the actual construction is like 8 years. So you can say like on average, we are rising at 1 meters per day. And then lastly, in terms of speed, we have on average is about every 4 minutes, we were able to finish 1 square meters of curtain wall. Safety, a lot of people are involved in constructing a super high rise. If you go back to the history of skyscraper, you can tell like there's a lot of fatal accidents, whether it was in the Empire State Building or in the Sears Tower or even in Burj Khalifa. Fatal accidents involve the human's life. At the peak of the construction in this Ping An Finance Center, there were like almost 3,000 workers working day in, day out on the site, day shift and night shift. But we are very proud to report that we have 0 casualty within over the period of a decade. So before we start going into the details of the 3 points that I just mentioned, I would just give you a summary, a little background about the project. The project is located in Shenzhen. The site itself is 18,000 square meters, which is a very tight site for a building of this scale. And the total GFA is about 459,000 square meters. The tower itself is 593 meters in height, and it's a total of 118 floors above grade, and then another 5 floors underground, below grade. That would mean like we are digging into the ground to 29.5 meters. The structure itself is a center core with 8 megacolumns, and then there are diagonal mega braces, and then 7 layers of bell trusses. Structures. So the overall structures, the tonnage is like 680,000 tons of steel. And then the mega columns on the ground floor itself is weighing like 95 tons, just to give you a sense of the magnitude of the project that we are dealing with. And then it consists of like 4 tower cranes, and then each is about 100 tons. Just now I was mentioning the basement itself is 29.5 meters deep. Indeed, like the piles that goes down further is another 35 meters deep of hand-dug caisson, which Mr. Weng is going to explain. And the diameter of the piles are 8 meters. Just a list of the milestones of what has happened. We started the project in 2008, and then the excavation started in 2000 March, followed by the mat slab foundation completed in 2011 December. 2010 October, and then the steel will start building up above grade in 2012. This is a series of photos showing the sequence of where we are. The building has moved in for a year now. So from here, I will just pass the floor to Mr. Weng to explain about the details of how we get the height, the speed, and also the safety.
Thank you, Florence. Good afternoon, ladies and gentlemen. Following is my presentation on the second part of construction award finalists of Ping An Finance Center. Ping An Finance Center is to be called PAFC in the following presentation. The construction of PAFC lasted 8 years. Many difficulties were encountered. We extracted the difficulty as 3 parts. Just mention the height, speed, and safety. In the height, I'm going to present the difficulty induced from the construction of PAFC. The second one is speed. This section shows that what we have done to get higher speed during construction of PFC. The third one is safety. This section is the last, but not the least. I'm going to present the safety measure held in PFC. Okay, go to the main body. Otherwise, it's not enough time to complete the presentation. Height. What difficulty we encountered from height? We know that the higher the building is, the deeper the foundation is required. The foundation was constructed between 30 meters and 60 meters below ground. So before the construction of foundation, we need to build a protective enclosure. The protective enclosure was piling wall. The piling wall is common as natural supporting system. Its construction also common. Why we adjust the construction of piling wall? It's not because of its difficulty in construction, but the precaution to control its natural deformation. We are not talking about to control the deformation about 20 or 30 millimeters. We are talking about to control the natural deformation within 4 millimeters. Why? In order to, it is because we have one metro line and one high-speed railway adjacent to PAFC as shown in the diagram. Both were existing. The metro line was in service when PFC construction. You can see from the diagram. Metro line is on the top, and the high-speed railway is on my left-hand side, your right-hand side. So what we did at the design stage, we set out some criteria as design parameter, including construction of main building independently. Second, we set out soil disposal using disposal vehicle rather than hoisting machine. Therefore, it came out with the solution by using double ring natural support. One side decided with regular ram, the other side decided with a big opening, just like this one. Then we will carry out numerical simulation to evaluate its deformation. Also, we carried out analysis on pile-soil interface while soil be removal. Therefore, it was designed to construct bore piles with 5 layers of natural support and waterproof curtain for the northern side. The remaining sides were designed to construct bore piles with 4 layers of natural support, waterproof curtain, and 2 layers of soil anchors. Yeah, that's right. What result did we have? It was end up with reduction of construction period by nearly 10%, and natural deformation was 2.5 millimeters. This show the construction stage of the natural support, and then what result we did, we have. It was end up with reduction of construction period by nearly 10%. And the natural deformation was 2.5 millimeters, which was just 60% of the limitation, as mentioned before. Another one difficulty induced from the height was hand-digging piles with large diameter, 8 meters. We have eight numbers of 8 diameter, 8 meter piles. We can be measured how big is this. Not many cases using as large as diameter 8 meter as pile in building projects. We prepare the piling holes by hand digging down to minus 25 meter. And then the blasting method was used to explode the pile holes down to minus 30 meter or even deeper to 35 meters. In more detail, prior to excavate, it was required to stabilize the pile holes. Grouting was applied to the bedrock fixture, and then some mini piles were constructed around the casing of the hand-digging piles. Besides, it was pre-drilled before excavation, and then, as mentioned, as normal practice, it was excavated further 1 meter per single day. So this picture can show each layer 1 meter, 1 meter, 1 meter. At the end, some achievements were gained as shown in this slide. Wrong way. This is the short video show the excavation and the pile construction. And then, at the end, some achievements were gained, as shown in this slide, including the development of the control of the micron deformation of the surrounding environmental of extremely complex foundation pits, etc., etc. I'm not going to go through point to point. Another difficulty were induced from the height was the construction of mass slab. Its difficulty was because of Sydney's massive concreting technology. Actually, what is the problem? The problem is thermal cracking. That would reduce structural integrity. So, what do you think if thermal crack induced in everywhere of the mass slab is still safe? Of course not. I think the answer is quite obvious. No, of course not. So, what makes thermal cracks? Of course, it is due to the temperature. The higher the temperature is, the more thermal crack would be induced. Also, the higher temperature difference is, the more thermal crack would be induced. Where is the temperature from? It comes from the hydration of concrete reaction. So we need to reduce rehydration. How? We use less cement content in the concrete mix. However, this will result in a lower strain at 28 days. So the concrete design strain was decided at 42 days. Why 42 days? In concrete technology, we talk about strain of concrete normally at 28 days. Actually, this is 4 weeks, not a complete calendar month. 42 days are equal to 6 weeks. This is quite matching with the terminology in concrete technology. At the end, at the end, highest temperature was measured with 62.5 degrees Celsius. Besides, some additional achievements were gained, including the development of the first one, development of the high-performance concrete design mix, especially for massive concreting. And then we talk about the speed. In this point, I'm going to talk about our special structure. Another. Since time is not enough, should I jump? This is the speed we are talking about. How to accelerate the construction speed by using the hydraulic climbing formwork system. This slide shows the design of the hydraulics climbing formwork system. Actually, during the design of the hydraulic system, we consider many factors, including the adverse weather, such as typhoon, and we need to consider about the embedment in the core wall, because as shown here, our core wall is complex and varies zone by zone. The core wall actually is a major frame core wall outrigger truss natural resistance system. So many embeds required to fix before concreting. This shows another diagram show the system of the climbing formwork. This slide shows the in situ fixing of this hydraulic climbing formwork. At the end, by using this system, the core wall were constructed average 4 days per floor, and we got the highest speed at 2.5 days per floor. This is another challenging. We have using the casting steel. Why we need to talk about the casting steel? Because it is quite hard to weld and the thickness of the casting steel was over 200 millimeters. It's not really easy to control and to weld. And existing design code even the existing design code cannot tell us how to use the welding procedure and testing procedure. So our contractor did one full scale mock-up to test the welding procedure and verify the welding procedure and the test procedure. At the end, we did the welding to the casting steel with 220 millimeter thick, and the length of the weld was 7.5 meter, and totally passed one time. This is another equipment that we used to accelerate our construction. This is called a cloud platform. What's cloud platform? Actually, this cloud platform contains all the information on MEP drawings, so that our contractor, our supervising engineer, ourselves can use this information to inspect, also to supervise the work. This is another method method accelerate our construction. This method is called a top-down installation method. What is top-down installation method? I have a small video. This shows the top-down installation method. This method actually save our transportation time and feasibility on the installation location. What is that means? Because we can choose a one more good condition location to fix the pipes. Safety. This is the last section. I think I should jump to at the end. Safety management in PAFC actually there's two parts. One by our developer, one by the contractor. We did this group in our role, and how do we control the safety? One of the main points is by the payment. Control the payment is really up on the what have done on the safety rather than what have done on the work done. And we did the delegation of safety responsibility to the main contractor and the supervising engineer. And we did some research so that we can use these results into the project, also the other project. And some standardization and promotion by the main contractor, and some safety culture by the main contractor. Finally, at the end, I'm proud to announce our project is zero casualty. Thank you.